So let's do limits of trigonometric functions. So there's a rule, a theorem that says the limit of sine x over x as x is approaching 0 is equal to what? 1. And then there's also a limit of x over sine x as x is approaching 0. This one is also equal to what? To 1. So this is the theorem. Then let's do examples. So let's find the limit of 1 cos x over x as x is approaching 0. So when you're told to find the limit of this trigonometric function, what we are going to do is we are going to say we multiply 1 plus cos x times 1 plus cos what? Cos x. So what we are going to do is we are going to expand the numerator, which is this time this one 1, this time this one plus cos x, this time this one minus cos x, this time this one to be minus cos squared x, over here we don't do anything to the denominator, we're just going to remain with x times 1 plus cos x. Then you can see that this is positive, this is negative. So these, they are going to cancel. We're going to remain with 1 minus cos squared x over x 1 plus cos x. Remember, don't forget to be writing the limit as x is approaching 0, the limit as x is approaching 0. So here, we should recall that sine squared x plus cos squared x is equal to 1. So this one, you can write it as sine squared x is equal to 1 cos squared what? X. This part is the one which is there. So we are going to substitute this part by that part. So we are going to have the limit of what? Of sine squared x over x times 1 plus cos x. 1 plus cos x as x is approaching 0. Then this is squared. What it says, squared means we can write it as x sine x times sine x. Then this one we can write it as what? X times 1 plus cos what? X. As x is approaching what? 0. Okay. So this we can write them like this. Then we said from the theorem, it says that the limit of sine x over x is what? Is 1. So you can see that this one will give me what? 1, right? Then we can substitute 0 for what? For x, and 0 for what? For that one. So we're going to have sine 0 is what? 0. Sine 0 is 0. So we're going to have 0 over 2. Because 0 is 1. So 1 plus 1 is 2. So therefore we're going to say 1 times this one, which is just equal to what? 0. Okay? So what we start from here, we come here. Then example 2, we are saying we have the limit of x sine x over tan squared x as x is approaching 0. So what we are going to do here is we are going to change this tan into sine and what? Cosine. So it will be the limit of x sine x over sine x over cos x. Because the tan is squared, even the sine and the cos will be squared. As x is approaching what? 0. Then this one, when we divide it by that one, we are going to have the limit of x cos x, x sine x times cos squared x over sine squared what? X. Then this one, as x is approaching 0, then this one can also be written as the limit of x over one of this x, which is sine x, times this sine x there, which is sine x, over one of this sine x, which is sine x, times cos squared x over 1, as x is approaching what? 0. Then recall that the theorem said that we can also say x over sine x is equal to what? 1. So this one will be equal to what? This one will be equal to what? 1 times this one will be 1 times this one will be what? What is cos 0? 1. Cos 0 is going to have 1 squared, which is just 1. Okay? Alright. Then we have example 3. We are going to have the limit of sine 5x over x as x is approaching what? 0. So to find this limit, recall that the limit of sine x over x as x is approaching 0 will give us what? 1. Recall this. So this implies that if you have a limit of sine something over something, we are going to get what? 1 as x is approaching what? 0. You have something here that is equal to something there. We should get what? Something, this something should be equal to this something. We are supposed to get what? 1. So to make this 5x, the limit of sine 5x over what? X as x is approaching 0. To make this x, to make this part equal that part, we are going to multiply by what? We are going to say the limit of sine 5x over, to make this part, to make this part equal to that part, what we are going to do is we are going to multiply by what? 5. It will be what? 5 there. Then whatever you did to the numerator, also do it to the what? The denominator. As x is approaching what? 0. Therefore, we are going to have 5 times the limit of sine 5x over 5x as x is approaching 0. Which this one will just give us what? It will give us 1. Then 5 times, this one will give us 1 because of this. We said that the limit of something, limit of sine something that is equal to this something is supposed to get 1. So this is equal to that. Therefore, we're going to have 1. So our limit will be equal to 5. Then there's a theorem which says the limit of sine ax over x as x is approaching 0 is equal to what? To ai. So this is the theorem for this. Then how can you do this? As in the other way of doing this is just saying the limit of sine 5x over x as x is approaching 0. So what you can do is, since you want to make this part look like that part, we are going to multiply by 5 on the numerator and on the denominator. When we do that, we are going to have 5 times this one. We are going to have 5 times the limit of sine 5x over 5 times x. We are going to have 5x as x is approaching what? 0. Then this one, because this one will be thought as x and then this one will also be thought as x, we are going to have 5 times this one. The limit is 1, which is equal to what? To 5. Okay. Where is this other example? Other example, let's say find the limit of sine 11x over 3x as x is approaching what? 0. So here, to find this, what you need to do is we want to make 11 there, so we remove this 3 from here. Removing this 3 from there, you factorize it. You are going to have 1 over 3. Then you remain with the limit of sine 11x over x as x is approaching what? 0. We factorize this. Then you want to make this part look like that part. So to do that, we want an 11 here. So to do that, we need to multiply the numerator by 11 and then also the denominator by 11. Therefore, you are going to have this time this, you are going to have 11 over 3 there times the limit of sine 11x over this time this, you are going to have 11x as x is approaching what? 0. Then this part is equal to that part. Therefore, this one will give us what? 1. So we are going to have 11 over 3 times what? 1, which is equal to 11 over 3. Therefore, we have this theorem which says the limit of sine ax over bx as x is approaching 0 is equal to a over what? Over b. So you can see our a was 11, our b was 3. Therefore, 11 over 3. Okay? Today you're not saying anything. Now Zanda. Toba Zanda. So we have example 4, which is the limit of sine 7k over 5k as as k is approaching what? 0. So like I said, we want to make this part equal to that part. So to do that, the first thing is to factorize 5. To factorize 5, you are going to have 1 over 5 times the limit of sine 7k over k as k is approaching what? 0.